we are going to learn a very non-traditional method of identifying the square root. Now, this method you will not find typically in traditional textbooks. It is rather taken from the Vedic style mathematics. So, I'll start with a very simple example. This number is 196 that I need to find the square root of. Now, the first step what we do is we take two digits at a time and we make pairs starting from the rightmost digit, okay? So 6 and 9 make one pair, and whatever remains after that goes in a group by itself. So now we have two groups. Then the next step is look for the digit at the unit place or the ones place, that is 6. Then I'm looking for what one digit number you will square and you will find a 6 in its digit place. That will be 4, because 4 times 4 is 16, and there could be also 6. 6 square is 36, and it contains a 6 in its unit place, right? So that means what? That means my square root might be either a 4 or a 6 at the unit place. But I still need to find the other digit, because I know that the square root of this 3-digit number will be of 2 digits. We have identified one potential digit, which is at the unit place. We are still looking for the second digit, right? Now when you square root this, you need to follow this simple method. Find a number such that when you square becomes equal to or less than this number, whatever is the number in the last group here, and that is 1. So I say that I find 1, and 1 square is equal to 1, which is just equal to this group, and there is a 0 remainder. Okay, now this 1 right here, it goes in my second number here, second digit here, 1. That means that I have identified two potential solutions of this square root. It could be either 14 or 16. The third and final step is check out this remainder. This remainder is 0, and 0 is less than 1. That means I need to look for the lower number out of these two, and that becomes my square root. If this remainder would have been greater than this one right here, then I would have picked the higher number. But since it is lower, and I will say 14 is my square root. And you can check it right here. When you square 14, you get 196. Alright, let's take one more example. In this case, I'm going to take a 4-digit number. And my 4-digit number is 1936. Okay, it's a perfect square, we know. So as usual, I'll start making pairs. So 3 and 6 will go in one pair, and there are only 2 digits left. They can make one pair. So you have 2 pairs now. As usual, look for what is my unit place value, 6. How do you obtain 6? Which natural number, if you square, gives you a 6 in its unit place? That could be either a 4 or it could be either a 6, right? When you square both of them, you get a 6 in its unit place, okay? So that means my potential solution of the square root of 1936 will be a number that will have either a 4 or a 6 at its unit place. Alright, so we are done with this group. Done. Next, find a number such that when you square it, it becomes either equal to or less than this remaining pair that we have. Okay, so when I square 4, I get 16, right? And that is less than 19. The next whole number after 4 is 5. When you square 5, it becomes bigger than 19. So I don't take 5. I only stick to 4 in this case, because I have to find the square of a number such that it is less than or equal to this specific pair that we have. Okay, it is there now, and this remainder is 3 in this case. The final step, you take this 4 right here as a second digit of your potential square root, right? And it is either 44 or 46. The final step is I compare the remainder 3. Is it less than or bigger than the 4 that we used here? It is less than, correct? 3 is less than 4. That means out of these two numbers, I pick the lower as my potential square root. So 44 is my square root. Simple enough, right? Let's double check. I will take 44. I will square it. And I have my calculator here, and using the calculator I can say that it is 1936. So this method works again, correct? I'm going to give you one more example so that you can build a good understanding on this simple neat technique of Vedic mathematics, okay? The third example is 6084, large number again, okay? Pair 2 digits at a time, right? Then look for unit place value. It is 4. Which natural number when you square gives you a 4? Either it will be 2 because 2 square gives you 4 and that's a unit place value, right? Or you can take 8. When you make 8 square, it gives you 64 and 4 is again a unit place value. That means my potential solution for the square root of this number is either a 2 or a 8 at its unit place. Okay, unit place, right? I still need to find out what is that missing number in its first place or the tens place so that I can complete my square root. Okay, so for that I'm going to do the square root here and I need to find a number such that when I square it, it becomes either equal to or less than 60. Okay, and that number happens to be 7 because when you do 7 square you get 49 and 49 is less than 60. The next whole number after 7 is 8. When you make 8 square, it gives you 64. It is right here. And 64 is bigger than 60. So we cannot take 8. We have to take 7. Right? So this is a remainder of 11. Okay? So that means at least my second digit, which is 7, goes here. So I have to pick between either this 72 or 78 as my potential square root. Okay? Then the final step is you check out this remainder. It is 11, correct? Then compare this 11 with 7. This divisor that we had, right? 7 square. We compare these two digits. If remainder is bigger than this, I go pick the higher number. Had the remainder been lower than 7, I would have picked the lower number. But since 11 is higher than 7, then I will pick the higher number right here. So that means very easy that 78 is my square root. So let's check it back again. 78 square. What is that number? When I square it and I'm using my calculator, I find that it is 6084. So that means our method has given us 78 very quickly, correct? So this method is very simple and you can extend the same method to more than 4 digits as well. Okay, it's faster than any other method you will find out, but it is only limited to finding the square root of perfect squares only.